Now, Dr. Abdulrahman Baboraik, academic researcher and consultant in renewable energy, and the president and founder of the Arab Academy for Renewable Energy, Arbrina, will talk with us about green hydrogen production and storage technologies, current status, and future direction. Please, Dr. Abdulrahman.
Thank you so much, Mr. Muhammad. It's a great pleasure to have opportunities to participate in this great conference, and I would like to appreciate the chairman of Swiss University. It's a great pleasure, and I was very happy to hear in the beginning a great introduction that the specialists who are working in the steel industry in material manufacturing are interested in the green transitions, are indeed in this how to find sustainable material science to make a successful energy transition. Thank you for Dr. Ahmed and Dr. Iman. Your presentation and talk was a great introduction to start my my presentation. Mr. Muhammad, do you hear me?
Yes, Dr.
I hope the presentation is clear, and I would like to start with, I chose the topic about green hydrogen production and storage technologies, current status and future directions. As we are in Arbrina, Arab Renewable Energy Academy, focus on how to spread awareness about the new energy carrier is the hydrogen in our MENA region, because the MENA region has a great potential and there are a lot of investments in this green new carriers. In today presentation, I would like to highlight the role of hydrogen in the global energy transition. We will discuss a little bit about global hydrogen trade flows, hydrogen production, current hydrogen production, and the future of hydrogen production in the net zero scenario of carbon emissions, and hydrogen storage production methods, their advantages and challenges and opportunities, and the application of hydrogen across the energy system, and the hydrogen value chain, and finally the hydrogen production cost, and the technology readiness level of key hydrogen technologies. And here, where can specialists in material science can be engaged to make a successful energy transitions. And finally, the innovation, the role of innovation and R&D toward renewable energy or green hydrogen successful transition, and which the investment estimated in the MENA region and around the world. Over the past year, hydrogen has been identified as the most promising carrier of clean energy. In world that time to replace fossil fuels, to mitigate greenhouse emissions, and to address other environmental concerns, hydrogen generation technologies have become a main player in this energy mix. As you can say that there are 6 players to make a successful energy transition. As you can say from this chart, besides developing renewable energy and energy efficiency and electrification, hydrogen play a significant role and crucial role to achieve these scenarios. Because of this, we hear every new day, every new month, there are new investments from different countries around the world. And the countries also in the MENA region, such as Saudi Arabia, Egypt, Oman, have a significant position in this energy transition. As you can see from the map, the MENA region has a significant and crucial role to make this success toward green hydrogen, because its unique geographical location and its historical and it's considered historically the center source of traditional power such as oil and gas across the globe. So the current production of global hydrogen, as we know, started 70 years ago, because hydrogen are used in several industrial feedstock, and for ammonia, for methanol, for refineries, as a part of mix of gases in steel and industrial heat generation. So detected hydrogen production from around the world, it's up to 90 megaton. The world produce the hydrogen. So, but the majority of this hydrogen production is coming or is produced from natural gas and remaining from the coal and oil, which is make a significant role or a contribution in the greenhouse gas emissions and increase the carbon emissions. If we will discuss the hydrogen as a new energy carrier in the global market, the demand for hydrogen will be increased around 7 times, and the hydrogen production must also be much cleaner, and it's today much cleaner than the today's technology. So it must be produced from electricity coming from renewable energy. This is only the way to make the hydrogen a key pillar of decarbonization. For instance, around 80% of the 90 megaton used hydrogen in 2020 was produced from fossil fuels. This result in almost 900 megaton of carbon dioxide, which equivalent to the carbon emissions for Indonesia and United Kingdom. Consequently, if we would like to go cleaner in several power sectors, in several industrial sectors, we have to increase the production of hydrogen from low carbon technologies by 2050. Hydrogen can be produced, as you know, from multiple ways, from different sources. So to differentiate them, it has become known or widely known to use the color. Because of this, you hear green hydrogen, gray hydrogen, blue hydrogen, and others color. If we will say the process of green hydrogen, so we produce green hydrogen from water and green electricity, which comes from renewables, by using electrolyzers, which split the water molecule to hydrogen and oxygen. So we don't have emissions in this case. The traditional way of production of hydrogen production is a gray hydrogen, where we use natural gas as input, and we have hydrogen and considerable amount of emissions. While blue hydrogen is the new technology that capture the carbon dioxide and greenhouse emissions and store them underground storage. Here we call this type of hydrogen blue hydrogen. To be more specific, we can say, depending on the emissions from production process, hydrogen can be classified by color. Whenever the carbon generated from steam, reforming or gasification process, and is not captured, this will be gray hydrogen. And here the main important process is steam reforming, steam reforming and gasification, and the methanol or coal can be used as a source of power and heat. While the other technologies such as hydrogen, we use renewable energy, electrolysis, where turquoise hydrogen is when we use it's referred to the way of creating the element through a process called methane pyrolysis, which generates solid carbon. As such, there is no need for carbon capture and storage, and that then can be used as in several applications in the manufacturing of tire manufacturing or soil improvers. So we discussed that which hydrogen storage method production methods exist. So as we will depend or rely on hydrogen, green hydrogen, as the future energy carriers, to achieve and make great transitions and most economical and clean transitions, hydrogen should be used across energy system in several applications. For instance, as you can say from the graph, we have to use it in mid-temperature heating and road transport, in international shipping and aviation, chemicals, steel manufacturing, seasonal storage. However, green hydrogen, the utilization of green hydrogen behind the industrial sector has several challenges across the value chain. So it's right now we discuss how to use green hydrogen in industrial process, power sector, power to fuel or power to X, in heating process across different sectors, industrial, commercial, power sector or resident building sector, and transport. However, there are several challenges across value chain, and as research and the research and development should be supported, and there are several efforts required to make several technologies in different stages more mature, more economic, and the materials, the science of material, a great and important role, as Dr. Iman mentioned, that the material is considered developing sustainable and cheap economic materials, considers one of the fundamental of energy transition. So let's see how it's look like the hydrogen value chain. As you say from chart, the green hydrogen the value chain from production to consumption consists of multiple stages which interlink with wider energy sector. Each element has its own barriers and challenges. For instance, across the value chain, we have challenges, the big challenges in the hydrogen production stage. We have to develop a lot of technology, and the current material used in electrolysis, they are abundant, they are not cheap, they are rare material across the world. So we have to go ahead for organic fuel cell and electrolysis. If we would say or focus on transportation and storage, the storage of hydrogen is crucial element of this value chain because it helps renewable energy to make a seasonal storage. Hydrogen is only the way to storage the energy from renewable energy for more than several months, which can participate in the power sector to cut the power sheaving and the power demand in winter and in the summer peak. So furthermore, beside the storage stage in this value chain, the transport of hydrogen is essential when electrolyzers or the sources of renewable energy facilities are not close to location where hydrogen is consumed. It can be used, transported in a variety of ways, including by trucks, ship, pipeline. However, to efficiently transport hydrogen, it must be either be compressed, liquefied into other energy carriers such as ammonia. And we recently heard from the news, Egypt has made several agreements with key players or key manufacturers around the world about production ammonia, because Egypt has unique geographical location and the cost of producing hydrogen is cheaper than other location in Europe, for instance, because the solar and wind is has high technical potential. So liquefaction, transportation, storage play a significant role to future green hydrogen threat or the global hydrogen threat. And you, as a specialist in material science, we advise you to take a part of these great opportunities across the supply chain, because material costs play a significant role to increase the capex and opex across this value chain. And let's take an example about the volumetric and about the main challenge of hydrogen. Great that the energy sector has experience of transporting gases over long distance. However, hydrogen presents additional challenges due to its physical properties. For instance, it has high energy density by weight, around 33 kilowatt hours per kilogram, compared, for instance, to 13 or 14 kilowatt hours for methane, but has lower energy density by volume. It's around 3 kilowatt hours per cubic meter compared to 10 kilowatt hours per cubic meter for methane. So therefore, to transport the same amount of energy, larger volumes of hydrogen need to be moved. For this reason, hydrogen is treated to reduce its volume when being transported. So the currently available options are compression, liquefaction, treatment, and make a liquid organic hydrogen carrier or liquid hydrogen. As you can see from graph, the energy density for each of this status of green hydrogen, and the distance and the cost play also challenges. They are considered challenges. So the solution is to go to the liquid hydrogen storage to make us more economics. We know that we are really consider our environment and worry about our environment, but people will not go to the green hydrogen, to the renewable energy technologies until well over a cheap and sustainable option. For instance, right now, if we will say the cost of hydrogen, of green hydrogen, we will say that the hydrogen from renewables are more expensive than from coal and natural gas with capture. So here the rule of R&D and innovation to make and to reduce the cost of green hydrogen below to $1.5 per kilogram. Recently, there a leader manufacturer or producer who announced that the production of 1 kilogram of hydrogen will cost around $3 per kilogram. This is a great success. However, we need more efforts to get this cost down, and you know that the energy crisis around the world, which challenges across supply chain in all sectors, became more challenges, and became more difficulties across the supply chain, and the cost of various products increased significantly. So one of the most important things that we learn, our trainers and our specialists in renewable energy, it's how to identify technology readiness level for various technologies. And as you can say from chart, that the production stage, low carbon hydrogen production stage, and storage and distribution stage have the most technologies which are still in small prototype or in the first stages of R&D. So the rule of universities, research center, research companies, it's how to push these technology which are located from the first to fourth stage, and from fourth to 7 or 8 stage, to the maturity level, to the market. If we can do this, we can say yes, green hydrogen became more compatible, more cheaper than coal and oil gas sources. For instance, as you are a specialist in material science, you say in storage section and distribution section, there are several fields where you can invest or you can put your efforts during the master degrees, the PhD, or in your chapter to have a great position in the MENA region. For instance, metal hydrates and how to use current oil and gas fields to store hydrogen. Also, the liquefaction of organic hydrogen develops various materials which make energy storage, which make green hydrogen storage is more reliable, more efficient, more reasonable. And if you can say this chart where the B chart shows that hydrogen production and hydrogen storage has the most significant share from the hydrogen related patent, which have been registered from 2010 to 2020. So hydrogen storage it's around 21%, and hydrogen production 36% of this global contribution in R&D to develop a new technologies. Also, if we look at fuel cells, the main challenges in fuel cells is it's how to find more cheap and more efficient materials in cathode and anode and catalyst. Finally, I forgot to mention that the current investment in hydrogen sector and in green hydrogen sector will be increased significantly until 2050. If you can see from the table, in the production stage of the value chain, around 60 or 65 billions will be spent to develop the current technology and to make the energy net zero emissions scenario successful, economical, and the transportation and transformation around it take around 60 also or 70 billions of investment. Here you can take this as indicator. We have to put our efforts in real near future market to make a science, to make the study and the output of our universities in the industrial sector, not in the library, and stop it. Finally, I would like to highlight that, as I said before, technical potential for production hydrogen from solar and wind across the globe. The MENA region has a great potential where we can achieve 1.5 dollar per kilogram during energy production, especially from the Egypt countries and South of Africa and Middle East countries such as Saudi Arabia, because it has a potential wind power and solar PV. So as you can see from the map, around Middle East and North Africa came in the second place of the future market of the hydrogen around 2023. This number is a great opportunity to local university, local researchers, and students. As Dr. Iman said, it's not important if you are studying the material science, you can forget about others. No, you as students or postgraduate students can participate in future green transitions. Sorry, I forgot to. Here is the map which I discussed about that MENA region has a great potential, technical potential from wind and solar, which make it the most economic center for energy, for green energy production. And you can say it comes in the second place of the global market around 2030. So I hope you you became a little bit interested in renewable and clean energy technologies, and I invite you all to visit our portal Arabrina. We update every day the latest technology and the latest R&D and innovation in renewable and storage and green hydrogen technologies. Thank you all and wish you all the best.